Questions 1 through 4 on the 2006 Grade 12 Euclid Math Contest. What is the sum of the X-intercept and Y-intercept of the line 3x minus 3y equals 24? To get the X-intercept, you set y equal to 0. So let's do that. 3x minus 3 times 0 equals 24. And that will give me 3x is equal to 24, and therefore x is equal to 8. So that is my X-intercept. To get a Y-intercept, you set x equal to 0. So that's going to be 3 times 0 minus 3y is equal to 24. And this becomes 3y is 24, and therefore y is equal to negative 8. And the sum, therefore, of the X-intercept and the Y-intercept is going to be 8 plus negative 8. And that is, of course, equal to 0. If the lines px equals 12 and 2x plus qy equals 10 intersect at 1, 1, what is the value of p plus q? Because they intersect at this point 1, 1, that point will satisfy both equations. So let's first start with this guy. P times 1 is equal to 12, and very quickly we get P is equal to 12. And then let's go to the next equation, substitute our point. 2 times 1 plus q times y, which is 1, is equal to 10. That gives me 2 plus q is equal to 10, and therefore q is 10 minus 2, which is 8. And we are told to figure out the value of p plus q. Well, that's going to be 12 plus 8, and that is equal to 20. In the diagram, the line x plus 2y is equal to 12 intersects the lines y is equal to minus x and y equals x at points A and B respectively. What is the length of AB? So we've got this line intersecting this line here, so let's figure that out first. That's going to be y is equal to x, and x plus 2y is equal to 12, so we're going to probably have to isolate for one of these. Doesn't really matter which one, but obviously we have to isolate for one. If I isolate for x, I just get 12 minus 2y. Now to find the intersection point, we have to set them equal to each other. So x equals this and x equals that, so set them equal to each other, and we will get the following. Y is equal to 12 minus 2y, like that. Solving for y, and we get 3y is equal to 12, and therefore y is equal to 4. Y is equal to 4, and substitute that value back into either of those to get the x value, and you'll get x equal to 4. So that means this point B is 4. All right? So that takes care of point B. Let's do the exact same thing to figure out point A. These equations are now y equals minus x, and the same line actually, x plus 2y is equal to 12. All right? Pretty much the same thing. Isolate for x, 12 minus 2y. And in this one, x is equal to minus y. And when these are set to each other, we get minus y is equal to 12 minus 2y. Solving for y, you get y is equal to 12. Substitute y equals 12 into either of these, and you will get x is equal to minus 12. So that means this point A is minus 12, 12, like that. All right? Now we have to find the length of AB. Okay? The length is figured out using the distance formula. AB is equal to the distance between 2 points. So let's see here. 4 minus 12, so that's 4 plus 12 squared, plus 4 minus 12, all squared, all under the square root sign. And that looks like 256 plus 64, all squared. And that is the square root of 320. And this can be written, let's see, that's 64, so 8 root 5. And I think that should be good enough. Yeah, if you want, you can always put it in decimal form, 7.88. And there you go. That is the length of AB. Question number 2. The average of the digits of the integer 46 is 5, including 46. How many two-digit positive integers have the average of their digits equal to 5? If you have a number, let's say it is AB, where the first digit is A, second digit is 5. The average of those digits, of course, is A plus B divided by 2. And they are saying that they want a scenario where that average is equal to 5. So set that equal to 5. Therefore, A plus B is equal to 10. So we have to find all the two-digit numbers such that A plus B is equal to 10. All right, let's make a little table. A, B. So A cannot be 0, because if it was, it would not be a two-digit number. It would be a one-digit number. So the lowest A can be in terms of integer values is 1. If A is 1, using this rule that we've created, B must be 9. Right? Same thing for A equals 2. You just have to use the A plus B equals 10 rule, and we'll get 8. And then you just keep on going like this. 3, 7, 4, 6, 5, 5, 6, 4, 7, 3, 8, 2, 9, 1. And I think that's it. So how many did I get? How many two-digit numbers? 19, 28, 37, 46, 55, 64, 73, 82, and 91. And that's 9. 9 two-digit integers that have the average of their digits equal to 5. So now 9 is the answer to part A of number 2. Part B. When the decimal point is placed between the digits of two-digit integer n, the resulting number is equal to the average of the digits of n. What is the value of n? So let n equal AB. That's my two-digit integer. And let's try to understand what they're saying. They're taking a decimal point and putting it in between. So they're doing this. A dot B, a decimal B, And then they're saying that when you do that, the resulting number, which is A dot B, is equal to the average of the digits of n. The average of the digits of n is A plus B over 2. All right? So this is what we have to deal with. So this part, I will write it as A plus B over 10, because that is what it really is, right? Because if you have something like 5.7, it's 5 plus 7 over 10. And that's exactly what I did. A plus B over 2. So this is now something we can work with a little bit better, I think. All right, let's see here. Multiply, lots of ways of doing this. Multiply through by 2. Let's see, 2A plus B over 5 is equal to A plus B. Isolate the variables, A, and this becomes B minus B over 5. So therefore, A is equal to, get a common denominator, 5 and 5, so this will be 4B over 5. And then just bring the 5 over. 5A equals 4B. All right, 5A equals 4B. That is what we have to deal with. Okay, so just by inspection, if I look at 5A is equal to 4B, that's going to be true, for example, when A is equal to 4 and B is equal to 5, right? 5 times 4 is 20, and 4 times 5 is 20. Let's verify that. AB, my number, which is n, is now going to be 45. That's the number, 45. And then A dot B, that is going to be 4.5. And we have to see if this is indeed true. All right, well, 4.5, is it equal to a plus b over 2? Well, a is 4, b is 5 divided by 2. That looks like 9 divided by 2, which is indeed 4.5. So there you go. This was just a verification. This is basically the solution. And in the end, they just want you to figure out n. Well, we did that already. N is a, b, and a is 4, and b is 5. So the number n is 45. The average of 3 positive integers is 28. When the 2 additional integers s and t are included, the average of all 5 integers is 34. What is the average of s and t? Let those first 3 positive integers be a, b, and c. And if I take their average, obviously divide by 3, they tell you that is 28. All right? So if I just multiply through by 3, this will give me a plus b plus c is 84. Okay? The next part, they introduce 2 additional numbers, and they call them s and t. And they tell you when you do the average there, that is 34. So if I multiply through by 5, I'm basically going to get this whole sum equal to 170. All right? So this part, a plus b plus c, I just calculated as 84, so I'll put that there. Plus s plus t is equal to 170. Bring the 84 on the other side, and you just get s plus t is equal to 86, right? And then they want the average of s and t. Well, you get the average by dividing by 2. So there you go. The average s plus t over 2, that represents the average of those 2 numbers, is equal to 86 divided by 2, which is 43. So that's the answer to part C. Determine the coordinates of the vertex of the parabola y is equal to x minus 20 times x minus 22. If you have a parabola and its equation is in this form, a times x minus h plus k, then the vertex is very easily detected. It's just hk. So our task in this question is to get this equation into this form. So they gave it to you in this form, x minus 20 times x minus 22. All right, no problem. Let's get it into this form. So the first step, of course, is multiplying this all out. So we get x squared minus 22x minus 20x plus 20 times 22, 440. So collecting like terms, we got x squared minus 42x plus 440. Now, how do we get it in this form? Something called completing the square. Do you remember how to complete the square? If you do, that's great. If you don't, no problem. I'll teach you. Basically, you look at that coefficient. You take half of it, and then you square it. So in our case, half of 42 is 21. So you take 21 and you square it. Now, I can't just introduce something. If I do, I have to subtract that same thing. You see what I mean? I can't just add something to an equation. If I do, I have to equalize it. And that's what this is. And then, of course, don't forget that 440. Now, what happens is these terms now factor. And in this case, it's x minus 21 all squared. Okay? That's called completing the square. And then what's left here, this part we add. So minus 21 squared is minus 441 plus 440. So this becomes y is equal to x minus 21 squared minus 1. Oh, okay, great. So this is now in this format. Okay, so you tell me, what is the vertex? Vertex is hk. Don't really need to put that, but I just wanted to write it in. In our case, our h is 21 and our k is -1. All right, 21, -1 is the vertex of that parabola. Point A is the vertex of the parabola y is equal to x squared plus 2, and point B is the vertex of the parabola y is equal to x squared minus 6x plus 7. And O is the origin. Determine the area of triangle OAB. So here we go, probably in the same way. Well, the good news is this is sort of already in that form. You remember that form was y is equal to a x minus h squared plus k. Well, I'll write it in that form in a very obvious way. 1 times x minus 0 squared plus 2. See, this was already in this form. I just wrote it like this to make it even more obvious. So the vertex here, therefore, vertex is 0, 2. Okay, now the next one, y is equal to x squared minus 6x plus 7. This one requires us to complete the square. So remember, you take half of that coefficient, which would be in this case minus 3, and then square it. So that would be 9. And then, of course, you have to subtract the 9. And then plus 7. So that allows you to factor those first three terms, and in this case it's minus x minus 3 squared. And then those two combine in this case to give minus 2. So the vertex in this case is 3, -2. All right, so now we plot this, and the plot doesn't have to be, very pretty, because they don't really care about the graph. They just want you to figure out the area. All right, so in a very approximate way, let's plot all of these points. So the first thing is the origin. That's right here. That's just 0, 0. And then our first point we got was 0, 2. So approximately here, 0, 2. And the next one is 3, -2. So 1, 2, 3, -2. So here, 3, -2. And these 3 points form a triangle. So connect those 3 points like that. And we have to now figure out the area of that triangle. Okay, area is 1/2 base times height. And the base, doesn't really matter. I mean, I'll call this the base. And that distance is 2. And then the height, I'll call this the height from there to there. And that distance is 3. So we get 1/2 times 2 times 3 is 3. That is the area of this triangle, AOB or OAB. In the diagram, the rectangle is divided into 9 smaller rectangles. The areas of 5 of these rectangles are given. Determine the area of the rectangle labeled R. All right. Is a rectangle a square? Just want to ask that question. All right. Well, let's just start labeling this diagram. I'll just make it a little bit bigger. And what we're trying to do really is just label the sides, lengths of the sides. Okay, well, this one starting here, if the area is 1, and I'm just going to make them integer sides, make this easy for us. That means this is 1 and this is 1, the side lengths. So that means this is 1 and this is 1, the length of those sides. Now let's look at that one. That has an area of 3, and the only way that's possible if that length is 3. Length times width, that's how you figure out the area of a rectangle. So you just continue this process. If this is 1 and this is 1, like that, those are all 1s. And then this must be 2, the length of that side. All right? And all the way down here, this is 3. It's the same as this guy. So if this side, let's say, was x, 3x is equal to 5. So that means x is equal to 5 over 3. All right? So since this is the same as this, that side is also 5 over 3. Now let's try to figure out this side. Let's call that y. Well, y times 5 over 3 is equal to 10. So therefore, y is equal to 30 over 5, which is equal to 6. All right? So that means this is 6, that's 6, and that's 6. Correct? Well, we got it. We know that this is 2. That means this is 2, right? The length of those sides. And this is 2. So finally, r, the area of r, must be equal to length times width, which is 2 times 6. And that is 12. So there you go. Determine the area of the rectangle labeled R. Well, that area is 12. In the diagram, the circle with center 1, 1 passes through the point 0, 0, intersects the y-axis at A, and intersects the x-axis at 2, 0. Determine with the justification the coordinates of A and the area of the part of the circle that lies in the first quadrant. All right, so first we have to figure out the coordinates for A. And since the circle intersects the y-axis at A, really what we're trying to figure out with A is the y-coordinate, or the y-intercept is what I meant to say. So, do you know how to figure out the equation of a circle? It's x minus h squared plus y minus k squared equal to r squared, where hk is the center. Well, the good news is they give us the center. It's 1, 1, so we can figure out part of the equation very quickly. But r we don't know quite yet. But that's not a problem. We can figure out r, because r is just the distance from the center to B. That's one quick way of figuring out r. All right, let's do that. CB represents r, and using the distance formula, we'll figure that out. So 2 minus 1 all squared plus 0 minus 1 all squared, all under the square root sign. So that gives me 1 plus 1 square root, that's square root of 2. All right? So that's r, radius. So this equation becomes r squared, which is 2. So there you go. That's the equation of our circle. Now we can find A pretty quickly. Since A is the y-intercept, we find that by setting x to 0. So let's do that. Set x to 0 in this equation. That'll give me negative 1 squared plus y minus 1 all squared is equal to 2. So y minus 1 squared is equal to 2 minus 1, which is 1. And that means y minus 1 is equal to plus or minus 1, and therefore y is going to be equal to either 0 or 2. All right, so this is obviously 0, and this is obviously 2. So A is 0, 2, and well, the origin, I mean, you know that already, it's 0, 0. So there you go. We just got our value for A. I'll write it again. A is 0, 2. So that was the first part of what they actually asked. Determine the coordinates of A. Now we have to determine the area of this circle, but only in the first quadrant. So only this part right here. We do not want, I guess, let me use a different color. We do not want this yellow part. All right. So how do we figure that out? Well, there's several ways of doing this. I'll just do it the way I guess I'm most comfortable. And that way is I have to show that AB is the diameter of the circle. Okay? Now, the way I'm going to do that is I'm going to first draw the line AB figure out the equation, and then show you that the center, 1, 1, lies on that line. Okay? That will show that that is indeed the diameter. So here we go. Move this up a bit. So line AB is what I'm interested in. Now, like all lines, it's going to have the equation of the form y is equal to mx plus b, right? And the good news is we have 2 points already on that line if I were to join A to B. But we have to prove this. We can't just say, well, yeah, AB is the diameter. Saying that is not enough. We have to prove it. It looks like the diameter, but we have to show that it is. All right, no problem. Let's use our 2 points, 0, 2 on AB and 2, 0. If you substitute in the first one, 0, or either one, it doesn't matter, right? Let's put in the first one, 0, 2. That gives me 2 is equal to b. So immediately I just got b. And then put in the second point, 2 for x this time and 0 for y. That gives me 2m. And since I already got b, I'll put that in. And this means that m is equal to negative 1. So very quickly I got the equation of that line. It's minus x plus 2. The equation of line AB. Now, I have to see if this point C11 is on that line. When x is 1, what is my y coordinate? Well, it's 2 minus 1, which is 1. So the point 1, 1 is indeed on that line. So that shows that the center is on that line, and therefore that line is indeed the diameter. The line AB is the diameter since the center 1, 1 is a point on that line. All right, so now we have to figure out the area of the circle, but only in the first quadrant. So how do we do that? Well, the good news is that since that's the diameter, we can figure out the area very quickly. I'll call this S, S1, and I'll call this S2. Any letter you want, really. So if you look at this, that region, this region right here, I'll sort of draw it in red. That's really half a circle. Now, if I take away this triangle, that will give me S1, S2. So let me write that out in words here. That region, S1 plus S2, is equal to half the circle, right? Pi r squared divided by 2 minus the triangle. So here we go. S1 plus S2, pi r squared. Well, we figured out the radius earlier was root 2. So root 2 squared is just 2. So 2 pi over 2. And then the area of the triangle is 1/2 base times height. And if you go back and look at that, the base is from here to here, which is 2. And the height is from here to here, which is also 2. So it's really just 2 times 2. So that looks like it's pi minus 2. Okay? Now that's the area that we don't want. So to figure out the area that's only in the first quadrant, we take the area of the entire circle and subtract from it S1 and S2. And that will give us this area, which is the area in the first quadrant. All right? So to get the desired area, we would take area in quadrant 1 is the entire circle, pi r squared, minus S1 plus S2. Right? Makes sense? So pi r squared, again, we had root 2 was our value for a radius. So root 2 squared is just 2. And then S1 plus S2 we just figured out was pi minus 2 in brackets. So this becomes 2 pi minus pi plus 2, and that is pi plus 2. So that is the answer to this question, 4B.